Okay, let's continue on the bonding video before. I'm just going to share the screen again. All right, this is where we were, right? If the arrows were to move this way on an sp2 carbon, which has a double bond, you get one carbon taking a negative charge and the other carbon taking a positive charge. So this is a carbanion, this is a carbocation, all in one place, right? So that's where we left off. What if there's another way to push arrows, which is even more, adding a little bit more complexity and fun. Suppose you have CH3, say, no, let's call it A and a B, right? So we said that's the way, right? Then this becomes A plus, this becomes B minus. If it is A double bond B, and that does that, it becomes A plus B minus, right? That's the summary of the previous video. There's another way to move arrow. You can take A, B. There are two electrons, right? This is two electrons. You can move one electron on one side, the other electron on the other side. Right? What the heck is this? Once again, both electrons are gone, so there's empty space. So you have empty space. And then you have B, but then A has one, B has one, right? Similarly, if you have a double bond between A and B, and you do the same thing, one this way, you have A, right? These are called fishhook arrows. Fishhook, right? Fishhook arrows. It's only a single electron, only one electron, only one electron per arrow. These kinds of arrows, 2 electrons per arrow. They both move, okay? That's how you know it. So let's look at this. Suppose you have H, 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 say C, H, sorry, H, H, and you did the same thing. You do this one side, what happens? You get H, 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 dot, right? That's the electron that is moved. And this side, you have the H, H, H as well, correct? So what's the formal charge on this? 4 minus 1, right? There's 1 there. And minus half of what? 1, 2, 3, 4, 5, 6. 4 minus 3 minus 1, that's a 0, right? That's the same here. So when you have someone says CH3, CH3, giving you 2 CH3 dot, that's what it means. This is the advanced way of notating that, right? So that means ethane splits via this process to 2 methane radicals, right? Two methyl radicals. So ethane cleaves something to give 2 methane radicals. That's what they say, what they mean. Ethane cleaves. So what is this here? What do you write here? Terms, right? Let me just get rid of this. So ethane cleaves to 2 methane radicals. So what? So this here is. So if it cleaves with this arrow, it's called heterolytic. Heterolytically. If it cleaves this with a fish hook, called homolytically. So this we should say homolytically, right? So ethane cleaves homolytically to give two methane radicals. This is what it means, okay? So this is how bonds break. So now with respect to what about if you have CH? What if this cleaves homolytically with fishhook? What do you get? Now it's still connected because this bond is not only one bond is being broken. So you get a radical, but there are two, right? So it's a diradical. Diradical, right? It is still there. Again, the formal charge on these is 0, 0, just like it was before, right? So keep this in mind, okay? Now with that, I'm going to stop this video because we introduced the concept of homolytic cleavage, the fishhook arrows, and how a single and a double bond can split with a fishhook arrow, right? There are no charges when it's doing fishhook arrows. There's no charge developed on either side. But when there's a full arrow, there's charge developed on either side like a battery, right? So let's stop here, then we'll move on.